Applying for a Department of Energy SBIR or STTR Phase 1 grant requires dedicated effort. Small businesses that wish to compete for federal dollars to fund research and development efforts must invest the time required to understand the objectives of the DOE topic to which they are responding, and then prepare a compelling written response to the DOE Funding Opportunity Announcement, or FOA. The goal of this series is to allow other small businesses which are hoping to take advantage of the SBIR STTR program to learn from the experts. Founded in 1991, Ohio-based Faraday Technology Inc. is no stranger to the DOE, SBIR, and STTR programs. With 15 employees, Faraday develops intellectual property for its clients and performs low-rate production in the electrochemical engineering field. We sat down with Dr. Jennings Taylor, known as EJ, and Dr. Maria E. Inman at Faraday headquarters in Clayton, Ohio, to glean insight into how they prepare a DOE SBIR or STTR application. It all starts when DOE releases its topics, which it does twice a year.
The day the solicitation comes out, I download all the topics. I send them out to all of the principal scientists and to EJ, and then I give them a deadline to send me back their suggestions within a specific template that I've given to them. Once we get all of everything back, EJ and I go through the topics one by one, and then we decide what's a go, what's a maybe, and what's a no. And then we respond back to the principal scientists to give them their writing assignments.
Faraday has always taken a team approach to writing proposals. Maria, who has been with Faraday for 19 of its 24 years, acts as the clearinghouse and gives the proposal a unified, coherent voice.
Everyone in the company is involved at some point in the writing process, but no one writes a proposal by themselves. So if someone is new to the company, we might give them a section of the proposal to write, maybe the ID of the problem or maybe the statement of work. And then someone else from the company, me or EJ in particular, will craft the rest of the proposal. So we can introduce them to the process of writing a proposal over time, section by section. Everyone in the company contributes to a proposal. I might write the commercialization section, someone else will write the idea of the problem statement of work, they'll put together the materials budget, I'll put together the full budget. It's really a team effort. No one writes a proposal here all by themselves.
Faraday includes subcontractors on about half of its proposals, typically universities and companies, but also national labs. While some relationships have evolved over time, some also have come from previous projects.
Typically, when we're working in an area that we identify and we say we have a potential competitive advantage there or something that would use our technology platform, we then sort of scan the literature. We look at patent literature as well as technical peer-reviewed literature. And in that, you can sort of identify by citation tracking where the sort of key papers are, and therefore the key authors, and then the key institution that those authors are affiliated with. Often the way we will involve them, some of our work with DOE is in the high energy physics area. And so clearly you have to have some very sophisticated, very costly tests that can really identify or qualify our technology. So we need to work with the DOE labs in that case. And so we're working currently in high energy physics with Jefferson Lab and Oak Ridge National Laboratory. In other cases, we might be developing a process technology that has a lot of industrial use. In aiding the development of the technology, it's often important to have modeling support. And so we will work with universities to work in that area.
Involving a new partner takes a lot of time and effort. Faraday recommends allowing as much time as possible to make this happen. They also engage in several strategies to meet potential new partners.
We have a lot of relationships with various universities and companies, but we're always looking for new people to work with. And we find those in different ways. One is we go to conferences. We will go to an Electrochemical Society conference, MSNT, something like that. We'll listen to talks, we'll go up and talk to professors or company people afterwards, engage them, see if there's a mutual area of collaboration. We also scan the technical literature, like anyone else in this profession does, and then EJ will also scan the patent literature. That's another way that we find people, is are they citing our patents?
Scanning the patent literature is something with which EJ is quite familiar. Being a patent agent himself, he tries to respond only to solicitations where patentability is not only attainable, but optimal.
It goes back to our business model. Our model is typically to work and commercialized through strategic partners. So these are folks that would have market channels, typically large companies that are selling into a commercial market, sometimes government market, but more often commercial. So therefore, the key thing that they want is they want their technical solution. That's very important. But in addition, they then want the competitive advantage associated with that solution. So as an example, we may solve a technical problem for deburring gears for Ford Automotive Company, which we've done. They may say, okay, this is great, we have the technical solution, but now how do I keep my competitor from getting that? And so the patent becomes part of that whole equation, if you will. So it's not only the technology, but it's also the IP that goes along with it.
When it comes time to prepare and submit a proposal, both EJ and Maria support the PI by trying to find partners and clarifying the commercialization pathway. Often, potential partners are actually involved in writing sections of the proposal. By bringing in an industry expert as a partner, this enables you to fulfill technical gaps and, more importantly, understand the market needs.
And then we'll ask them to help contribute to the writing of the proposal as much as possible. For example, if it's a technology area that we're not an expert in, we might ask a university professor or a company to help us write the ID of the problem, because we may not be as familiar with that. We'll concentrate on the technical approach, what we will bring to it, and then we'll ask them to help us craft the statement of work. If they're going to do some of the work, what portion of that statement of work are they going to write? They have to write their own task.
The heart of a DOE technical proposal is the work plan. For companies that have never developed a work plan, this could seem somewhat daunting, but Faraday takes a systematic approach to simplify the process.
With regard to the work plan, there are two parts to that for us. And the first is the technical approach. How do we describe the innovation itself? And for us, there's a sort of a standard sort of boilerplate description of our pulse reverse electrochemical engineering technology that we can insert into most proposals, and then we adjust it and tweak it for the application. Say for polishing versus plating, for example. Following the technical approach is the statement of work. And the statement of work generally consists for us of 6 tasks: a kickoff meeting, some sort of equipment design or build, process experiments, characterization, an economic analysis, and then reporting and program management. Those are sort of the fundamental tasks within our statements of work. Within those tasks, we may describe experiments that would be used to achieve the technical objectives of the phase 1. One thing to a caution perhaps is to always make sure that your phase 1 statement of work is doable. Don't try and bite off more than you can chew. Don't try and solve the entire problem in the first 6 months, because the phase 1 is about just demonstrating proof of concept. It's not about creating a new product that's ready to go to market. That's what the phase 2 is about really developing and taking it fully to commercialization. So you're trying to de-risk the DOE's investment in phase 1 by simply showing, yes, this has merit, yes, this can be done. And so for that, you have to choose your measures of merit appropriately. And that's where industry, for us, comes in, because industry can come in and say, yes, that is something that will mean something to me. That makes sense as a metric. And we often ask our clients to do our analysis for us, because if a large company comes in and says, I tested your coating and it met my specifications, that means more than if we do a test and we say, well, obviously we passed.
To this day, Faraday still contacts the topic manager at DOE when responding to a FOA. Although many new companies are hesitant to reach out, EJ thinks this is a great habit to cultivate.
There's often follow-up. Can we talk to the topic author? It's very important when you're writing a proposal to know what the author wants, the topic author wants, because typically as scientists or engineers, we think of what we want to do, but what's important is what does our client want us to do. I think technical people are trained to give answers. That's what we do in our graduate work and undergraduate as well. But often we will try to give answers before we understand what the question is. So it's really key to understand what is the topic asking for, not what you want to deliver or what you think the topic author should be looking for. And then again, talk to the topic author. And I think again, for the very first proposal, it's very important to have partners because you probably have limited resources in terms of laboratory facilities. And so you want to leverage that with universities, federal labs, etc. And that's exactly what I did when I began Faraday.
Another key recommendation Faraday makes is to always look at the review, whether you win or lose.
We always try and get a review back on a proposal that wasn't funded because we want to know where did we not communicate effectively. We may disagree with the reviewer. We may think that technically they're wrong, but that suggests to us that we didn't make our case well enough. So for us, it's a learning opportunity. You have to sit down, you have to really study the review, look at it objectively, and say, how can we do better next time? Even if we win a proposal, we want to get the review back because that suggests that we did something right in our proposal, our crafting of the proposal, and there was maybe some aspect where we communicated well, and we want to know what that is too so we can repeat that for future proposals.
Faraday is a great example of a small business that has benefited immensely from SBIR and STTR dollars. By emulating the perseverance and the technical approach to putting together a winning DOE Phase 1 proposal, other small businesses can hopefully use the program to fund their unique innovations while addressing the Department of Energy's needs.